Okay, example 2 of the approximate method. Here we've got this frame, same as last time-ish. We actually have W1 here, W2 here, and W2 here. So it's like different loads, but same overall concept. So let's get into this. Let's split this up into our main things. We're going to have D, E, G, H, and D, F. E, F, sorry, it sounds like D, F. Okay, so we can start here with D, E. Going to start to look like that. Then we're going to have GH right here. Look like this. And then we're going to have EF right here. Okay, sweet. And this for when it's cut. Put these where they should be. All right, sweet. So here's our basic outline for the approximate method. And let's find this. This is 24. So let's do 0.1 out of 24. And then let's do 0.1 out of 16. This is going to equal 2.4, 1.6. So now if we do 20 or 2.4 times 2, 24 minus this, looks we're getting 19.2 for these lengths here. GH is also going to be 19.2. And then 16 or 1.6 times 2, 16 minus this, looks like it's going to be 12.8. Okay, awesome. And then what's this going to be? This is going to be 2.4, 2.4, and then 1.6. All right, sweet. What's this length here? Or what's this distributed load here? Let's see, this is going to be W, for D, it's going to be W1, so it's going to be 3.3 times 19.2. It's going to be 63.36 divided by 2 is going to give us 31.68. And this over here is going to be 31.68 right there. And then we're going to do 3.3 times 2.4. It's going to give us 7.92. What's this one right here going to be? That's going to be the whole thing. So it's going to be 3.3 times 24, which is going to be 69.3, divided by 2, which is going to be 34.65. Not. Why not? It totally is 34.65. Okay, sweet. Now that we have this, we can actually find MD. Which is going to equal 1.2, 2.4 divided by 2 times 7.92 plus 2.4 times 31.68. MD is going to equal, let's see, 1.2 times 7.92 plus 2.4 times 34.65, 92. Ooh. Sorry, 31.68. Why did I write 34.65 here? 31.68. There you go. 85.5 536. Sweet. Now let's keep doing this for the next few. Oh, actually, there's answer 1 right there. So now moving on, and I believe this is going to be kip per foot. Yeah. Now let's find, let's see right here. We have 2.2 times our 19.2, 42. 24, divide that by 2, we're getting 21.12. Okay, sweet. And now 2.2, first off, this is 21.12 here. Now we're going to do 2.2 times 2.4, which is 5.28. And then right here for the shear, it's going to be 2.2 times 24 divided by 2. 2.2 times 24 divided by 2, 26.4. Whoops, I forgot to draw this. That's our MD. This is our MG. So now MG is going to equal 1.2 times 5.28 plus 2.4 times 21 point, was it 72? 12. Mg equals 57.024. And lastly here we have W2, so it's going to be 2.2 times 12.8, 28.16, divide that by 2, 14.08. Okay, sweet. So now we know that up here is going to be 14.08. Then we're going to have 2.2 times 1.6, which is going to be 3.52. And then what's this right here? It's going to be 16 times 2.2, which is going to be equal to, divided by 2, equal to 17.6. Okay, sweet. Here we have our moment E, and ME is going to be equal to, well, what's 1.6 divided by 2? It's going to be 0.08, or just 0.8, sorry. Jeez, gosh, dang. Watch too many cop shows. 3.52, 1.6 times 14.08. We have ME is going to be equal to 23 or 25.344. Awesome. Now moving on to like the hard part about this. Actually, if I move that up a little bit, I could probably take this and just move that like here. Awesome. Okay. Start with joint D. So that's joint D right here, scribbly dibbly. And it's going to have one known force here and one unknown force here. This known force is going to be DE, which we know since that's going up 35.64, this is going to go down 0.65. I'm so freaking dyslexic today. I have no clue why I'm scraping things all over the place. And because we know that at this point it's going clockwise, it's going to go counterclockwise this way. So So it's also going to have a moment here, MD of 85.536, which means that we're going to have the exact opposite of both of these. That's going clockwise, it's going to go counterclockwise, and this is going to go up 34.65 and 85.536. All right, and if this was a column here, column DG, it would look much like this here with the 34, 34, and the 85, and the 85 like that. All right, now on to the next joint. What are we trying to find here? Actually, joint B. Oh, we don't need to find this. I'm trying to find A. We can cut to the chase. So let's cut to the chase. Forget I did any of that. Because in all actuality, this whole time, this was actually the magical joint E. Okay, and at joint E, we have DE, which we know here. That's a force coming down. And then over here we have EF, which we know right here. Force coming down. This one's going to come down 17.6. This one's going to come down 34.65. And this is the hard part now with the moments, because this is going to have a moment and that's going to have a moment. Now what's the direction of these moments? For this one right here, we know this is going to be DE, but it's going to be on this side. So on this side, the moment's coming counterclockwise. So we know here it's going to be going clockwise. This is going to come up, and this is going to come up 85.5. And here, joint EF, we know here it's going clockwise already, so it's going to go counterclockwise here. And it's going to go counterclockwise 25.34. So then what's this right here going to be? This right here is going to be, where did we find this 85? Where was it? Right here. 85 minus 25.344. That's our moment. And what's our force reaction? Our force reaction's here. That's going to be 34.65 plus 17.6. So this is going to be 52.25 here with a moment, probably this way. What's the superior moment here? It's this one. So it's going to have more counteracting it to balance this out. So moment here of 60.192. Now on to the next joint. Honestly, we can do the next joint right over here on the side, just to give us the most room possible. This is going to be joint H. Okay. It's right here. It's going to look like this. And with joint H, we've got this that we've just found out. It's going to come down 52, and it was going clockwise. So now it's going to go counterclockwise, 60.1. And what's this one here? This is GH, and we know this one. GH is going down 26.4, and it has a moment. Let's see, its moment's going to go this way, which is counterclockwise. So this one's going to go clockwise, and it's going to go clockwise 57.0. So then what's this reaction here going to be? Well, this is going to be our 52.25 plus a 26.4, which is going to be 78.65. And what's our moment? Well, we've got 60 this way and 57 that way. So let's do our 60, subtract 57.024. We actually have a moment here. Let's see, that's the larger one, so it's going to be helping out this way. Of 3.168. And does that seem possible? Let's see. My apologies, my apologies. This is going the other way. There, it's actually adding them. Sorry. So this moment here is going to be MB is equal to 117.2. My apologies, my apologies. Negative 117.2. And that's MB right here equals negative 117.2. Makes sense. If we took this as our positive sign convention, it is going this way. Kip foot. So there you go. And I guess BY, just for the heck of it here, is going to be 78.65, but I can't prove that with my software here. I can only prove that MB is negative 117.2. But I mean, if that's right, why not? You know, crazy.